Hello everyone, this is Suvendu Sir, your physics mentor, and welcome to our lecture number 7. And in lecture number 7, we will continue our class 10 physics topic, that is our light, reflection and refraction. This is our ongoing chapter actually. So up to class 6 or lecture number 6, we have completed the image formation in case of concave and convex mirror. So now proceed towards the relation between focal length f and radius of curvature r in case of a spherical mirror. We know the simplest formula is f is equal to r by 2, and which is valid both for concave as well as convex spherical mirror. Let's prove this formula. Relation between the radius of curvature r and focal length f of spherical mirror. So now we will proceed towards this topic. So let us consider this is your our concave mirror, and here so this represents the aperture of our concave spherical mirror. Now after this we will draw the principal axis. The midpoint or geometrical center of this mirror, that is called your pole, and this line represents the principal axis. Now we can mark this is the pole and xpy is our aperture. Next is this is the focus suppose, and this is suppose the center of curvature. And let us consider this incident ray. This is the incident ray which is coming parallel to principal axis, and after reflection, as it is coming parallel to principal axis, the reflected ray after reflection passes through the focus. So this is our reflected ray. ये हो गया हमारा incident ray, and this one is our reflected ray. And in this diagram, which one is our point of incidence? Let's mark the point of incidence as k. K is our point of incidence for this incident ray. Okay. So at the point of incidence k, how can we draw the normal? We know to draw the normal at any point on a spherical mirror, join that point to its center of curvature. अभी देखो मैं उसको join कर रहा हूँ. Join k point with center of curvature, and this represents the, now this line represents the normal at the point of incidence k. So this is incident ray, this is normal, so this will be angle of incidence I, and this is our angle of incidence r. So k is what? K is our, in figure, k is the point of incidence, and what is ck? ck is our normal drawn at point of incidence k. At point of incidence k. And what is focal length in the diagram? The distance of the focus from the pole of a spherical mirror. Now from the pole to focus, ये distance क्या होगा? This distance is our focal length, and from pole to center of curvature, ये distance क्या होगा हमारा? This is our radius of curvature. So as these distances are measured from the pole which is opposite to the direction of incident ray, so we can mark it as minus f, and this is your minus r. I think it is clear. Next come to the Next part. So as from the laws of reflection, angle I is equal to angle R. So in figure, angle I is equal to angle R. क्या मतलब क्या है? देखो, ये है तुम्हारा I. The angle IKC is equal to FKC, which implies the angle IKC is equal to angle FK. Again, और एक चीज दिखाई दे रहा है, देखो, consider these two lines are parallel to each other and ये देखो intersection. So ये angle I means this angle is also angle of incidence I. तो इसको हम लोग लिखना चाहिए. तो in the figure ये एंगल क्या होगा? This angle is our angle of incidence I also. ओके. तो अभी तुमको दिखाई दे रहा है इन ट्रायंगल एफ के सी दिस टू एंगल्स आर इक्वल एज एंगल आई इक्वल टू एंगल आर. तो उनका फ्रंट फेसिंग साइड क्या होगा? बराबर ही होगा. तो इन ट्रायंगल इन फिगर इन ट्रायंगल FKC, these two angles are equal. FCK equal to FKC. FCK angle is equal to FKC, which implies that is angle I is equal to angle R. Then ये दो एंगल इक्वल होगा तो उनका फ्रंट फेसिंग साइड मींस, देखो, जो तुम्हारा FK is equal to FC और we can say KF is equal to FC, which implies KF is equal to FC. This is our conclusion. इसके बाद क्या लिखना चाहिए हमको? देखो, now after this we can think another one. See, if the aperture of the mirror is very small, ये जो मिरर का aperture very small हो जाएगा तो then क्या दिखाई देगा तुमको? Then K lies very close to P. If the aperture of the mirror is very small, this is the principal axis, then क्या होगा? Then K lies very close to P. उसी चीज को लिखना चाहिए. So ये K, when K lies very close to P, we can say FK is equal to FP. When K lies very close to P, ये पॉइंट K हो जाएगा तो FK आंसर, FK length is equal to FP length. So when aperture of the mirror is very small, or you can write when aperture of mirror is very small, then K lies very close to P. That means we can say KF is equal to PF. KF is equal to PF. लेकिन ये जो प्रीवियस इक्वेशन देखो, KF equal to FC मिला था हमको, KF equal to FC. तो from equation 1, KF is equal to FC. तो ये दोनों इक्वेशन को कंपेयर करने से क्या मिलेगा? PF is equal to FC. PF is equal to FC. ये मिलने के बाद now we can write in figure what is PC? PC is equal to, the length of PC is equal to PF plus FC. PF plus FC. Now PF का वैल्यू FC के साथ बराबर होगा. When PF is equal to FC, now we can write it as PC is equal to PF plus PF. That will be equal to 2PF. And PC का आंसर देखो लिखा हुआ है minus R is equal to 2 times of minus F. That means R will be equal to 2F, or we can say f is equal to focal length f is equal to r by 2. And remember, this formula is valid both for concave and convex spherical mirror. So in this way we can prove the relation between focal length and radius curvature in case of spherical mirror. देखो कितना आसान तरीके से हम लोग इसको सॉल्व कर चुके हैं. तो ये फॉर्मूला किसके लिए वैलिड होगा? What we have to write in this case? Now see, we can write नोट पॉइंट पे ये लिखना चाहिए. इन नोट पॉइंट यू कैन मेंशन r is equal to f by 2 is valid both for concave and convex spherical mirror. Convex spherical mirror. इस चीज को बस नोट करते चलो. इसके बाद देखो एक छोटा सा क्वेश्चन दिया है. सपोज क्वेश्चन क्या है? इफ radius of curvature of a concave mirror is 36 centimeter, then find its focal length. Suppose this is your mentioned question. तो आंसर क्या करना चाहिए? देखो पहला चीज, फर्स्ट यू हैव टू राइट द गिवन डाटा वेयर radius of curvature is mentioned 36 centimeter. लेकिन keep this thing in mind, in case of concave mirror the focus and center of curvature lies in front of the mirror. So concave mirror के पास क्या है? रियल फोकस एंड रियल सेंटर ऑफ कर्वेचर अवेलेबल है. तो इसीलिए द डिस्टेंस ऑफ दैट इज योर रेडियस ऑफ कर्वेचर वी कैन टेक फ्रॉम पोल टू center of curvature, which is opposite to the direction of incident ray. So that's why we have to write r is equal to minus 36 centimeter. So now we know the relation f is equal to r by 2. That will be equal to minus 36 by 2, that is minus 18 centimeter. Convex होगा तो you simply mention plus sign. So this is about this answer of this question. So इसके बाद now I will proceed towards the magnification in case of spherical mirror. Already we have covered the ray diagram in case of spherical mirror, and we have observed that in case of concave mirror, for different position of objects in front of the mirror, the position of images are different. तो इसके हिसाब से the size क्या होगा? Size is also different मिल रहा था हमको. So based upon the position of object, position of image can be determined, and different position of image means different size पे मिला हमको. Keep this thing in mind. So basically size of object का comparison से, object size तो fix ना. So in comparison to the size of object, how many times the size of image is greater or lesser? That is your magnification. So what is the significance of magnification? It determines how many times image size is greater or lesser in comparison to the size of object. That part we have to write. Next give heading magnification. तो उसका इंट्रोडक्शन हो गया. Magnification, always remember, magnification is denoted by the letter small m. Okay, ये magnification को कंप्लीट करने से पहले we have to finish mirror formula. Mirror formula के बाद we will discuss the magnification. तो इंट्रोडक्शन तो हो गया मैग्निफिकेशन का. डायरेक्ट इसके बाद हम लोग इसको शुरू कर पाएंगे. नेक्स्ट वन इज मिरर फॉर्मूला. देखो ये जो फॉर्मूला तुम्हारा क्लास 10 सीबीएसई सिलेबस में अवेलेबल है, उसका डेरिवेशन तुम्हारा सीबीएसई सिलेबस में अवेलेबल नहीं. दैट इज एक्सक्लूडेड पार्ट. इंक्लूडेड पार्ट क्या है तुम्हारा सिलेबस में? क्या है? ओनली यू हैव टू थिंक अबाउट द फॉर्मूला एंड प्रैक्टिस द एप्लीकेशन ऑफ मिरर फॉर्मूला in its proper way. So mirror formula क्या है? देखो, it is the relation between object distance, image distance and focal length of a spherical mirror. The required relation is 1 by V plus 1 by U is equal to 1 by F. Very simple formula. What is V? V is our image distance, U is our object distance, and F is our focal length. So now in this left side we can write what? We can write the relation between object distance U, image distance V, and focal length of a spherical mirror, and focal length F of a spherical mirror is given by which formula? 1 by V plus 1 by U is equal to 1 by F. This is our required mirror formula. This is our what? Required mirror formula. And इसमें देखो, this is our required mirror formula. Okay. Now what is object distance? Remember one point. Object distance means, don't think that it is the distance of object from the pole. तो ये इनकम्प्लीट हो रहा है थोड़ा. तो कैसे? देखो मैं क्या लिख रहा हूं. Next, give heading object distance. It is the distance of position of an object on principal axis from pole of spherical mirror, from the pole of the spherical mirror, from the pole of the spherical mirror. It is the distance of position of an object on principal axis from the pole of spherical mirror. That is called object distance, and it is denoted by the letter U, small u. Then next term is image distance. Same as previous, we can write it as V. So it is the distance of the position of image on the principal axis from the pole of spherical mirror, This is our image distance. And the relation between U, V and F is 1 by V plus 1 by U is equal to 1 by F. This is our required mirror formula. And it's a complete derivation that is available in class 12 physics. And the topic is our geometrical optics chapter. Geometrical optics. Okay. So after mirror formula, our aim is to discuss what? Our aim is to discuss the magnification content. So what is magnification? Now see, already I have discussed the introductory part. Now let's give heading magnification. And it is denoted by which letter? It is denoted by the letter small m, not capital M, that is small m. So intro पे क्या लिखना चाहिए? In comparison to the size of object, how many times the image size is greater or lesser? How many times the image size is greater or lesser? That can be determined by magnification. that can be determined by magnification. एंड उसका वर्किंग फॉर्मूला क्या है? व्हाट इज द वर्किंग फॉर्मूला ऑफ मैग्निफिकेशन? सिंपली मैग्निफिकेशन m is equal to height of image divided by height of object. It is defined as the ratio of height or size of image to size of object. It is defined as the ratio of height of image to height of object. So simply we can denote it as small m is equal to hi divided by ho. This is the working formula for magnification in terms of object height and image height. Yes, and in ray diagram and also in new Cartesian sign convention. So you have to focus upon your lecture number 5 and 6. This is our ongoing lecture, that is our lecture number 7. In lecture number 5, we have discussed new Cartesian sign convention. Yes. So in that case, we have discussed how to apply the sign convention. What is the sign of height of image, height of object, object distance, image distance, focal length, radius of curvature, etc. In a very detailed manner I have explained. So go to that lecture in order to complete the syllabus, okay, in order to gain the knowledge from that content. Okay, so this is the magnification formula in terms of height of image to height of object. And also remember, in terms of object distance and image distance, in terms of object distance u and image distance v, the magnification formula will be, but in terms of object distance u and image distance v magnification m is equal to minus v by u. Moreover, we can write m is equal to height of image by height of object, or that is equal to minus v by u. And also remember, you have to use the sign convention of v and u, object distance and image distance का sign convention use करना चाहिए ये फॉर्मूला पे, नहीं तो गलत हो जाएगा न्यूमेरिकल. Keep this thing in mind. So this is about your magnification in terms of u, v and hi and ho. Basically इसमें दिक्कत क्या होगा? When magnification can be positive or negative, देखो इसमें डिस्कशन होगा. और एक चीज देखो, न्यूमरेटर पार्ट में क्या है, देखो हाइट ऑफ इमेज उसका यूनिट क्या होगा, मीटर, एंड हाइट ऑफ ऑब्जेक्ट डिनोमिनेटर पे है, उसका भी यूनिट क्या है, मीटर. सो कैंसिल हो जाएगा. सो मैग्निफिकेशन इज कंप्लीटली यूनिटलेस क्वांटिटी. इट इज यूनिटलेस क्वांटिटी. मैग्निफिकेशन is unitless quantity. Yes, I think it is very clear to all of you. Okay, so now proceed towards our next slide. In next part, what we have to discuss, in which case your magnification is positive and in which case your magnification is negative. Now listen, this is your note point. Yes, in case of real and inverted image, in case of real and inverted image, तो real inverted image में क्या होगा बोलो? In case of real inverted image, always your height of image क्या होगा? Of downward height with respect to principal axis दिखाई देगा, that will be negative, and your height of object तो क्या होगा? It is upward height with respect to principal axis. कोई भी रे डायग्राम चूज करो जिसमें रियल एंड इन्वर्टेड इमेज फॉर्म हो रहा है, तभी जाकर समझ पाओगे. ओके, टर्न योर पेज, कॉपी में टर्न करो पेज को, आराम से समझ पाओगे. देखो तो तुम्हारा मैग्निफिकेशन आंसर क्या होगा? m is equal to hi by ho. so this is your negative number divided by positive number. तो रिजल्ट क्या मिलेगा हमको? नेगेटिव. तो याद रखो, when magnification is negative, the image is completely real and inverted. That is the important point. Second thing, in second point what we have to write, in second point, in case of virtual and direct image, in case of virtual and direct image, in case of virtual and direct image, your height of image, that will be the upward height with respect to principal axis, that is positive, and height of object क्या दिखाई देगा तुमको, that is positive. This is also upward height with respect to principal axis. In each and every ray diagram we have accepted, we have considered the object in this case as such this case. So HO क्या होगा, positive. तो magnification क्या होगा, height of image by height of object. तो positive number divided by a positive value क्या मिलेगा तुमको, positive. So when m is negative, the image is real inverted, and when m is positive, the image is virtual and direct. This is the important part of this content, that is your magnification. देखो मिरर फॉर्मूला, मैग्निफिकेशन, ये टोटल कंप्लीट हो गया. आज का इस सेशन पे लास्टली हम लोग और एक न्यू फॉर्मूला डिराइव करेंगे. देखो छोटा सा डेरिवेशन, कुछ भी दिक्कत नहीं होगा तुमको, बस यू हैव टू पे योर अटेंशन इन ऑर्डर टू लर्न दिस फॉर्मूला सिस्टमेटिकली. How I am going to write, how I am going to derive, now that depends upon your concentration, attention, only upon your attention. Only upon your attention it depends. So now trick, देखो we know the mirror formula क्या है, हमको बोलो. We know 1 by v plus 1 by u is equals to 1 by f. Very good. 1 by v plus 1 by u is equal to 1 by f. और एक बार लिख रहा हूं, we know your 1 by v plus 1 by u, that is equal to 1 by f. This is our mirror formula. तो ये जो फॉर्मूला तुमको दिखाई दे रहा है, इसका कितना साइड है, एक है तुम्हारा LHS पार्ट, दूसरा तुम्हारा RHS पार्ट. तो दोनों पार्ट में तुम लोग क्या करो, मल्टीप्लाई u ऑन बोथ साइड्स, multiplying u on both sides, what you will get, u by v plus u by u is equals to u by f. देखो ये कितना होगा, u by v plus 1 is equals to u by f. That means u by v का आंसर क्या होगा, u by f minus 1, that is your f, एलसीएम होगा u minus f. तो क्या करो, अभी दोनों साइड पे -1 मल्टीप्लाई करो. ऐसा क्यों कर रहे हैं हम लोग, बाद में पता चलेगा. तो दोनों साइड पे क्या होगा, -1 मल्टीप्लाई करने से दिस टर्म विल बी माइनस u by v, ये क्या हो जाएगा, f minus u by f. तो अभी क्या करो, रेसिप्रोकल ले जाओ, इस साइड पे रेसिप्रोकल ले जाओ. सो माइनस u by का रेसिप्रोकल क्या होगा, माइनस v by u, एंड इसका रेसिप्रोकल क्या होगा, f by f minus v. And we know in case of mirror minus v by u is magnification. तो मैग्निफिकेशन का 10 m is equal to f by f minus u. ये एक शानदार फॉर्मूला देखो तुमको मिल रहा है. दिस इज द रिलेशन बिटवीन m, f एंड u. मैग्निफिकेशन, फोकल लेंथ एंड ऑब्जेक्ट डिस्टेंस, दिस इज द रिक्वायर्ड रिलेशन. देखो वही मेन फॉर्मूला से हम लोग इसको लिख रहे हैं. बस पहले मल्टीप्लाई करना चाहिए u ऑन बोथ साइड्स. आफ्टर दैट देन देखो माइनस v by को अचीव करने के लिए, टू अचीव द माइनस v by u टर्म, वी हैव टू मल्टीप्लाई -1 ऑन बोथ साइड्स. आफ्टर दैट रीअरेंज इट, यू विल गेट द आंसर. अगेन मल्टीप्लाइंग v ऑन बोथ साइड्स, दोनों साइड पे v मल्टीप्लाई करने से देखो m, f एंड v के बीच में रिलेशन पता चल जाएगा. कैसे, देखो मल्टीप्लाइंग v on both sides, क्या होगा, v by v plus v by u, that will be equal to v by, तो v by v तो 1 हो गया, plus v by u, this will be v by f. So what is the value of v by u? V by u will be v by f minus 1. तो आंसर इज f, तो तुम्हारा एलसीएम हो गया. इसके बाद v minus f. देन यहाँ पे v by u मिल रहा है हमको, लेकिन मैग्निफिकेशन का फॉर्मूला क्या है, माइनस v by u. सो मल्टीप्लाई -1 ऑन बोथ साइड्स, दिस विल बी माइनस v by u, एंड ये टर्म उल्टा हो जाएगा. देखो f minus v by f, f minus v by f. ओके, तो माइनस v बाई u का मतलब क्या है, मैग्निफिकेशन. दिस इज इक्वल टू f माइनस v बाई f. f माइनस v बाई f. क्लियर हो गया. तो देखो ऑब्जर्व, अच्छे से ऑब्जर्व करो. सो मैग्निफिकेशन का चार फॉर्मूला तुमको मिल गया एक्चुअली. एच आई बाई एच ओ इक्वल टू माइनस वी बाई यू इक्वल टू एफ बाई एफ माइनस यू. अनदर वन इज एफ माइनस वी बाई एफ. दिस इज द रिलेशन बिटवीन एम एफ एंड वी. So these are the required formulas in case of magnification. m is equal to, बार बार मैं बोल रहा हूं देखो, m is equal to हमको मिल रहा है एच आई बाई एच ओ. सेकेंड वन इज माइनस v बाई u. थर्ड वन इज f बाई f माइनस u. नेक्स्ट वन इज f माइनस v बाई. ये देखो किसका फॉर्मूला, ओनली मैग्निफिकेशन का फॉर्मूला. मिल गया. सो एज पर द क्वेश्चन यू हैव टू अप्लाई द फॉर्मूला. देखो दो तरीके से मैं एक्सप्लेन कर दूंगा न्यूमेरिकल को. आफ्टर दिस लेक्चर नंबर 7, इन लेक्चर नंबर 8 बेसिकली वी विल सॉल्व न्यूमेरिकल. इफ पॉसिबल at first I will discuss the uses of convex mirror and concave mirror. After that we will solve numerical, or whatever may be, we will solve the numerical at first. After that we will discuss the uses of plane mirror, convex mirror, concave mirror, characteristics of plane mirror, characteristic image formation in plane mirror, सारा का सारा चीज. ओके, बहुत सारा कंटेंट अवेलेबल है. characteristics of image formation in case of plane mirror. Okay, so forget about that thing, only focus upon this formula. This is about your magnification, and with this we have successfully completed our lecture number 7. So on behalf of your support, thank you so much. On behalf of your support, I am able to complete all the lectures. So give your comments on the comment box. So thank you and have a nice day. Stay tuned for next update. Kindly share this channel to your friends for their benefits. Okay, have a nice day ahead.